This is TechCrunch. General Motors revealed Tuesday a new battery chemistry called Lithium-manganese-rich, LMR, which it says should slash costs while delivering driving range that's just shy of the most advanced batteries on the market. With LMR, we can deliver over 400-mile range in our trucks while significantly reducing our battery costs, Kurt Kelty, GM's Vice President of Battery, Propulsion and Sustainability, told TechCrunch. LMR will also dramatically reduce the amount of nickel and cobalt compared with GM's most advanced cells, two critical minerals that aren't readily available from domestic sources in the United States. Today, the Chevrolet Silverado EV uses nickel-manganese-cobalt NMC cells to drive 492 miles on a full charge. That impressive range comes with a hefty price tag. The electric truck start at over $73,000 for the general public. A fleet version costs less. GM is planning a version with cheaper lithium iron phosphate LFP cells, which would drop the price by $6,000 but also cuts range to 350 miles. The new technology would preserve the LFP price cuts without sacrificing as much range. GM says the new cells will be cheaper for a few reasons. For one, manganese is cheaper than cobalt or nickel. The LMR chemistry will have 0 to 2% cobalt, 30 to 40% nickel, and 60 to 70% manganese. That's significantly less than today's leading NMC cells, which are up to 10% cobalt and 80% nickel. Previous attempts at manganese-rich batteries have tended to degrade quickly. GM thinks it has cracked the problem. The automaker experimented with a range of materials and manufacturing processes to arrive at the current formulation. LMR battery packs will contain prismatic cells instead of pouches. Today's Ultium batteries use the latter. Kelty said switching to prismatic cells, which have a rigid shell, will help the company build a battery pack with more than 50% fewer parts. It's a huge cost savings we'll get, he said. GM has big plans for LMR, with the chemistry potentially spreading throughout the EV lineup. Andy Uri, business planning manager at GM, said that LMR could take up a huge chunk in the middle of the market, pushing LFP to entry-level vehicles and pricey NMC to applications that need long range and high energy density. The new cells will be made by Ultium Cells, GM's joint venture with LG Energy Solution. Through Ultium, the two companies have invested billions of dollars in battery manufacturing in the United States. Both have been pursuing LMR for years. GM has more than 50 patents on LMR, though LG has also been working on the technology itself. Kelty acknowledged it's possible that LG could make its own version of LMR cells that don't infringe on GM's patents, making the chemistry more widely available. It'll be interesting to see how this all plays out, Kelty said. GM's LMR research has been underway for a decade. Its efforts kicked into high gear in the last couple of years as engineers successfully produced large format cells similar to those in EVs on the road today. GM has made about 300 large format cells so far, and its testing regime equates to around 1.5 million miles of typical driving, said Kushal Narayanaswamy, Director of Advanced Cell Engineering at the automaker. That leaves just a few short years for the company to modify its existing manufacturing plants to accommodate the new chemistry and then scale up production. Scaling, in particular, tripped up the first Ultium cells. Kelty is confident that GM can hit the 2028 target. It meets all our performance metrics. We have a partner that's going to manufacture it, and we've got a manufacturing location, he said. The other thing is the supply chain is much more local than high nickel or LFP, so we're really incentivized to do this. There's a lot of things coming together here that really make us want to go quickly.